Right, so I thought we'd finished, but we haven't. So we've got functions here. Again, what's really neat about this, question 21, and you can get 2 marks for this, definitely can. This is the inverse of f. Now, remember how we do this. We start with our x journey and BIDMAS. We times by 3, then we take away 1. Inverse means literally going the other way. So we have our x, we add 1, and then we divide by 3. Yes, that is it. That is it. Now this one here, a bit more challenging. G goes into F. G goes into F. So that means I take my G and I place it into my F, which means times by 3, take away 1. And that equals 2, big guy, F going into G. F going into G. Add 4. So there we go. Looks really kind of messy, but that's fine. It's question 21 after all. It's allowed to be messy. Let's multiply this out. We get 3x squared plus 12 minus 1. Always be careful you don't rush things. So I'm not going to rush this one. Multiply that out. Again, you can use FOIL, but trust me, last thing I would do, but you get that. Okay, so if you did it nice and slowly, you would get something like that. I hope I'm right. If I'm not right, I'm wrong. And there we go. Plus 12 minus 1 is plus 11. And now all of this, I can tidy that up, double that, so it's 18x squared minus 12x. That's 5 times by 2 is 10. Now tidy everything up. I've got 18x, most x squareds here, so bring that across to that side. So that becomes 15x squared because you take away from both sides. Take away 11 from that, so that becomes that. And look, that's exactly what they wanted. So I got it right. Happy days. And then lastly, hope it's last. Yes, it is. Says it here. Well, hey, last one. There are only red counters and green counters in a bag. So red and green and nothing more. A counter is taken at random of the bag and the probability the counter is green is 3/7. So in the first instance, the probability it's green, okay, is 3/7, which has got to be green out of all of them, doesn't it? That's got to be what it is. But then it says the counter is put back in the bag, handy, but then 2 more red and 2 more green. Okay, so I've got 2 more red and 3 more green are added. And now the probability that's green, so now the probability it's green is 16/13. And that equals green, which is the G plus the 3, the original set plus that, all over the R and the green plus the 5 more. So that's what you've got there. And now it says find the number of red counters and green counters. Okay, we can do this. How do we do this? Okay, I just don't like fractions. I mean, you can cope with fractions, but why? When you can multiply it out. So I am going to multiply everything out here. That multiplied up there, so it's 3r plus 3g equals 7g. And that's nice and tidy, so I can get rid of 3g from both sides. So 3r equals 4g. Not like we have in Bath 4g, no g. Anyway, multiply that with that, so I get 6r plus 6g plus 30 equals, because I did that times that, every term here times by 6, and then 13g, and then 13 times 3 is 39. Let's tidy that up. I've got more g's here, so get rid of those 6. So I've got 6r equals 7g, because I got rid of that, and that becomes 9 there. So now I've got all of this, I've got to try and relate them. Look at that, 3r, 6r. So what I can do is I can double that, which means I double that. Now, if 6r equals blib and 6r equals blob, then blib equals blob. proper maths language, that. Wow, wow. Look, 8g equals 7g plus 9, so obviously a g must equal 9. That's so cool. And if I know what g equals, I can put it into one of these, like here. 3r equals, what is it saying? 4 lots of g. And if g is 9, 4 9s are 36. And therefore r must be 12. Red counters 12, green counters 9. And that is paper 1 done. Now, time for dinner.